Hello everyone, my name is Ajay and today we are going to discuss about AWS Load Balancer. Before we expand and explore the functionality and the benefit which is provided by AWS, let's try to understand what is the network load balancer and why do we need it. So load balancing, it basically refers to efficient way of distributing your incoming network traffic to pool of the backend servers. What it means, today you might be launching any sort of the web application or the website, and tomorrow you become very popular. So you might be starting receiving a lot of requests, can be maybe a million of requests, which is coming from the internet. Or maybe you are hosting a website which is for your internal purpose only. And if you have an employee like 50,000 employee or 60,000 employee and they want to access something internally within your intranet, you basically need to host a web server. And since one web server is not going to be sufficient in terms of the load it can carry, you need to deploy a load balancer in front of those servers. So let's try to understand what it means to you, what are the options available, and how it works. So load balancer, you can divide basically into two different categories. One is going to be your local load balancing, and second option is going to be the global load balancing. So local load balancing, it means maybe you're hosting some application in your data center and you want to do the load balancing for all incoming traffic across pool of the resources. So for example, at this time, I assume all these users, they are a part of your internal network and you have intranet and you have a pool of servers. So you want to deploy a load balancer in front of the pool of servers. So whenever you receive multiple requests, for example, the one request comes to the load balancer and this load balancer decides, let's route it to the first backend server. When the second request comes to the load balancer, let's distribute the load to the and take it to the second server. That's how it works. And it is the same scenario, but when you talk about global load balancing, it means I'm assuming all these users, they are geographically distributed and your website that is publicly available. So what do you need to do to maintain the latency, maintain the response time? You want to distribute your load based on the source. If my source is coming, let's assume this load balancer I host in US. And when I'm talking about global load balancing, it means I will be having the same setup, what I see here, in different geographic region. So my second LV, it might be located in EU. So now, when we talk about the source, if they all are coming from US, within the US, I can maintain some sort of the latency. So basically, I want to redirect all the traffic which is coming from here to this load balancer, which is located within the geographic region. But when this user is coming from EMEA, I don't want this traffic to go to US. Instead of that, this traffic should hit to the load balancer, which is in EU. So you can play with this kind of routing, basically with the global load balancing. If I go to the history and tell you the name of the vendor, which is going to be the F5, when we talk about local load balancing, that is basically I'm referring to LTM. And when I refer to the global load balancing, I refer to GTM. Same functionality is also available when we talk about the cloud. So what are going to be the key reason why do you want to load balance it? So first reason is going to be the high availability. No matter what is the load, which region users are located, my application, it should be always be available. My load distribution, that is a key. Whatever the number of requests I'm getting from the users, I need to do some sort of the load balancing. Then for security reason, that is basically for the application, I need web application firewall, which I can integrate with the load balancer. And SSL offloading, that is also one of the very common use case for the load balancing or load balancer. Then management. Our management should be very, very simple. If I want to do or perform some sort of the maintenance, I should have a centralized functionality which is available to, maybe I want to perform maintenance on one of the server. So I should be able to take that server out of from this pool, and that should not disrupt the traffic which is coming from the user. Cost effectiveness. That is also a key component. Whenever we are designing this kind of the setup, we need to consider the cost also. And automatic scaling. Automatic scaling, that is also a very, very common feature. Maybe I have a pattern on one day, the number of requests it reaches pretty high, and that time it should not happen during the peak time my website is going down. It should be always available, and I should have some sort of the capability to add more resources in the pool to make my application available and serve the purpose. And whenever we are talking about the load balancer, the first thing comes in mind, there are a variety of load balancer, the functionality available in the market. What is a load balancer which is basically going to suit us? So two options are available. The load balancer supports L4 or L7. When I talk about the L4, it means I'm talking about OSI layer, transport and network. This is going to be the 3, this is going to be the 4, and they both come all together. So that is a one functionality you can get it from the load balancer. Second thing, my load balancer, if it supports L7, then I'm talking about the upper layer, which is going to be the application, presentation, session, and transport. So for example, if I host a application which is going to be the HTML web application which support SSL and TLS, it means I need to be very, very careful in terms of the capacity my load balancer is going to provide. And that capacity and the metrics, basically it comes when you look at the data sheet and it talks about this is my hardware load balancer, or maybe this is my software load balancer, and it gives you RPS, which is going to be the request per second, how many requests per second I can handle. Second, how many connections per second I can handle, and how many transactions per second I can handle, and what is going to be the throughput. So these are the things you need to verify before you design any sort of the load balancer. This is a list of very famous load balancer available in the market. One is going to be the F5, Camp, A10. You can go for Barracuda, Nginx, and Citrix. And there are more vendors. And why I'm discussing it, it gives you the option. Some of them you can go for the hardware-based load balancing. Some of them you can go for the software-based load balancing. And whether you are on-prem, whether you're on the cloud, you can also deploy the software version of this load balancer. For example, F5, it comes with the hardware also, and if you want to deploy and get the same functionality, you can deploy it on cloud. Same thing with others. Let's come back to our AWS and go to the AWS marketplace. And when you type the load balancer, maybe you can type the ADC. It gives you all the option what I have described earlier. You have a list of publisher. These many publishers or the vendors are available from where you can choose your software version of the load balancer, which you can deploy on cloud. It's going to be the Citrix, F5, Red Bear. These are the very famous and known names available. This is the one option available if you want to go for the external vendor from the marketplace. Second option is going to be you can go for services, which is basically developed and maintained by AWS, and we are going to discuss those. Load balancer in AWS, basically it is going to be the EC2 service. So you can go to the EC2 services and from there you can provision your load balancer. So when we go to the load balancer, you can see the type of load balancer which you want to use basically for the specified service which suits you. So there are type of load balancer. One is going to be the application load balancer. One is going to be the network load balancer, and third one is going to be the gateway load balancer. So application load balancer, as we all know it, we are talking about the application. If you want to do some sort of the content based routing for your services, which might be HTTP or HTTPS, it is suggested you should go for the application load balancer. If your services are basically on the TCP, UDP, and TLS, you can go for the network load balancer. And if you're using third-party appliances, which is deployed on the cloud, you can go for gateway load balancer also. This option, what you see on the bottom, classic load balancer, that is something hidden. Earlier, what was happening, these two functionalities were inbuilt here. So every time you need to launch a classic load balancer and decide whether you want to go for the application or you want to go for the network load balancer. Now that is being deprecated on August 15, 2022. This is not going to be available. So you will have only three options available to configure the load balancers on your AWS. In this section, we are only going to talk about network load balancer, and maybe in the next video, we'll talk about the application load balancer. So let's focus on the network load balancer here. And we are going to expand all the options what I have given you initially. What are the key reasons to use the load balancer? So one reason, and the first reason, was high availability. So elastic load balancing automatically distribute your incoming traffic across multiple targets, such as EC2 instances. It can be container, it can be the IP address in one or more availability zone. So these are my users, and I assume they all are on the internet. And the moment you create load balancer, so it is going to have the backend also, and those backend servers, they will be part of your VPC. And I'm trying to build a application, or I'm going to put those servers into availability zone. And the reason, if this availability zone goes down, at least I have my services up and running here in AG1. So I'm going to distribute my load here, and this is the availability or high availability on the server side. How about the load balancer? So the way it works on AWS, the moment we launch load balancer, it is going to ask you whether you want to dedicate this load balancer for one particular AG. That means it is only going to create one instance of load balancer, and from there you can redirect all your traffic. There is an additional option which is coming. You can add resources in availability zones. So while creating load balancer, you choose more availability zones. And the moment I choose those availability zone, it means if I choose availability zone AG2, it is going to spin or going to create additional instance which will be tied up with your AG2. Similarly, if I have AG3, that is going to be the third availability zone, and I choose it from while creating the load balancer, it is going to spin one more load balancer instance which will be tied up with this. There are some restrictions also. You can keep adding those availability zone, but once it is added, you cannot delete it. So that is something you need to keep in mind. It means now you have multiple instance of load balancer running, and your backend is also distributed. So both the places you have high availability. Second thing also comes, we call it ELB. That means it has the functionality of elasticity. And what it mean to you? It mean to me, this is something a managed services, and the moment your load is increasing, it is automatically going to provision the resources to handle that particular load. So this piece is also supports elasticity, and here you can keep adding your resources so that your application is highly available to the users. There's one more option which is available to you. Maybe you want to design your load balancing infrastructure like this. So instead of creating one load balancer and choosing multiple availability zone, we create load balancer and that to multiple and tied with only one AG. So for example, this is my first load balancer and that is tied with the AZ1. And I can go for the second one, that is going to be the second AG. This is the third one, which is going to be the third AG. And when it comes to the load balancing the traffic, I can leverage Route 53. That is also going to be the one of the AWS services, which can help you to distribute your load, which is coming from the internet. And you can do the routing, maybe which is going to be the based on the weight. So it is something which is similar to playing with the DNS. So Route 53, it is going to be the DNS. If, for example, I put some name for the A record and provide multiple IP addresses. So the moment the request from the user it hits to Route 53, it is going to be do some sort of the round robin and return the A record or the IP address from this list. So if I have a two, if I keep hitting the NS lookup, this IP keeps changing. It means it is going to be the DNS sort of load balancing. And that is to hit until the load balancer. And after that, load balancer is also going to have some sort of the algorithm which is going to decide what is the backend server which you are going to hit. This is one option which is available. Load distribution, that is very important topic when we discuss or design the load balancing services. So there are two options when you play with the transport layer, whether you are going to have the TCP connection or the UDP connection. So here we are going to discuss about the TCP connection. So if the request which is made from user, they all are TCP connections in nature. So how the load balancing works. You're not going to find any sort of the options to choose the algorithm like round robin or weighted, what it comes with other load balancer. But here for TCP connections, NLB selects target, and target is going to be these EC2 instance. And it is based on the hash algorithm. What it mean by the hash algorithm? If you look at the packet, your IP packet basically, it is going to have the source IP address, source port, destination IP address, destination port, and the TCP sequence number. These are the tuples, the 5 tuples, which is going to be used by load balancer which target will be hit it. So let's talk about the TCP sequence number. What will happen if I'm the user and I hit the load balancer for the same application? My source port, it is fixed. My destination port is also fixed. My source IP is also fixed. Destination is also fixed. So I need to have some sort of mechanism how to, if my first request, it hits this EC2 instance, when I send the next request, it should not go to the old one, rather than it should go and do some sort of load balancer. It means it should hit the second EC2 instance. So I need some unique value, and that unique value, it comes from the TCP sequence number. Let's talk about the UDP connection. So UDP connections we know is a connectionless, and you're not going to have any sort of the unique value which comes from the TCP. So the algorithm is completely based on the source IP address, source port, destination IP address, and destination port. It means these four tuples will decide which EC2 instance traffic goes to. So let's go for the same example. If this is my source, I'm hitting the load balancer, and this source creates multiple connections. So the bad part comes, source IP is fixed, my destination is also fixed, and ports are also going to be the fixed. So anytime I hit this load balancer, I will be only redirected to a EC2 instance which comes out from the hash algorithm, and that hash value is going to be the same. SSL offloading is also very common use case for the load balancer. So you get an option whether you want to terminate your SSL offloading your EC2 instance, or you want to do it on the load balancer layer. Managing that SSL offloading on the load balancer makes it simple. You just need to install a simple one single certificate here. But if you're going to have an environment like 100 of servers, then you need to install that SSL certificate and manage it per server basis. So that work, basically you can offload from EC2 instance to load balancer. And why do we want to do it? So couple of things to keep in mind. The EC2 instance and the kind of web server which you're running, for example, let's say it's a Apache server which you're running here. You need a lot of compute power, a lot of CPU on these EC2 instances to do the SSL offloading. So you need to decide or go for the higher category, which gives you better SSL offloading functionality. For example, if you go for T2 micro kind of setup, maybe it gives you or terminate 50 SSL sessions. And if you're a big organization who is expecting 10,000 or maybe 100,000 connections per second, you need to add a lot of EC2 instances here. So it's always better we offload that work to load balancer, which is a managed service and has got elasticity. So what it mean by SSL? So whenever we create the SSR on the server or maybe on the load balancer, it is going to ask how many bits of encryption bits you are going to have. So this is the example for the google.com. This is the public key, which is ECC 256 bits. And when I go for the Microsoft public key, it is using RSA 2048. So RSA 2048, you have option to go from 1024 to 4096. Normally, as a standard, you see 2048 bits of encryption, which is very hard to hack. though you have an option to go for 4096 bit of encryption. And if you go for that, it means you need more and more compute. But hacking this encryption, it is going to be very, very tougher. For example, if I say this is a 4028-bit encryption, and hackers might hack it or crack it within 10 hours, it doesn't mean if I go for 4096 that will be cracked in 20 hours. No, it might take ages or hundred of years to crack this kind of encryption. So higher the bits, you need better machines here. So better you offload your SSL to load balancer and let these EC2 instance just serve the content. Another option, the key reason is the management. Since we already talked about the SSL, it means instead of managing your SSL certificate for 100 of device, you can have the simple manageability on the load balancer. Top of that, if you want to do some sort of the maintenance which is going to be performed, maybe you want to do some sort of the redirection when your services are down, or maybe you want to do some maintenance on specific servers, you can take them out of pool, and from the user point of view, they will never realize you have some servers down. So if you take these two out, it means all the requests which is coming from these users, it will be redirected to active or healthy instances. Cost effectiveness, as I mentioned, if you want to do your SSL offloading on your these servers, these are going to be very, very high compute intensive devices. So since I offloading on your load balancer, I can go for the low cost instances and serve the purpose. And it also gives you the option for the automatic scaling. So if you're very popular or maybe the e-commerce website and on a particular day or you have a pattern that this particular time you see a lot many users, they do the shopping or they do some sort of activity. And at that time, you can also do and configure the automatic scaling. And once the load increases, you create more instances to share the workload. As I mentioned earlier, your load balancer is going to be the EC2 type or EC2 services. So when you go to the EC2 dashboard, you can see the option for the load balancing. It gives you an option to create the load balancer or to create the target groups. So target group is nothing, but it's just going to be the pool of servers where you want to redirect the traffic. So let's hit the load balancer and you can see the option create load balancer. So let's hit create load balancer as well. So once we hit the create load balancer, you see the basic configuration which you need to perform. So you need to give the load balancer name. So choose something which is sensible enough for you. And then we see a scheme, whether this is going to be the internet facing load balancer or this is going to be the internal. So as I mentioned earlier, if your application is internet based, you should go for this option. If it is something, a website which is going to serve your intranet users, then you should go for the internal. Then you have an option to choose the IP address type. You can go for IPv4 and you can go for dual stack. What it mean? I can have the IPv4 if I'm expecting all the users which is outside, they are going to hit or communicate over the IPv4. Or you might have a mixed sort of user. You want to give the IPv4 and IPv6 both the functionality. So option is up to you. And then we see network mapping. You need to define the VPC, and then you are going to have the listener. Listener means this is going to be the internet facing. This particular VIP or the IP, it is going to listen on this particular port. So this is internet facing, for example, and this VIP will be listening on the port 80, which is going to be the TCP. However, you have option, you can choose the protocol from here. You can, since we are talking about the network load balancer, you can go for UDP, you can go for STTP and TCP. Tag is something going to be the optional, and you see a option create target group. So once you create the load balancer, it is going to ask what is the target group where you want to redirect all this traffic, which is going to hit your load balancer. So we'll talk about that going forward. So the basic things to keep in mind, you need to create a load balancer. You need to create a listener. So listener is going to be the IP address belongs to your load balancer, and you need to mention what is the port it is going to listen on. Target group is a pool of servers where you want to redirect all the traffic, and health check is something how this load balancer is going to ensure whether you have a healthy host within the target group or not. If you have an unhealthy host, it should be automatically removed from the pool of the server, and rest of the healthy resources, they should serve the request which is coming from internet or maybe internal. Let's talk about the lab which I'm going to simulate here. So this, I created a VPC A which is going to have the boundary of IP address 10.10.0.0/16. I will have one load balancer, and I will have two AGs. The first subnet belongs to US-East-1A, and I have carved a subnet from IPv4 which is going to be the /24. This /26, it comes from the range /56 when you create the VPC. So this is my EC2 instance, and since it is up and running, this is the internal IP which get assigned to this. This is going to be the IPv6, and this is going to be the public IP address. And the reason I'm going to have the public IP address because I need to do or access these servers to do the website configuration or to turn on the web services here. My second server is going to be the native IPv4, so I'm just carved another /24 from here, and this belongs to 1B. So on a running instance, this is my private IP address, and 44.201.1.254.7, that is my public IP address. I have two instances running, so let's verify what is the IP address here. So these are the Linux AWS EC2 instance. So this is my internal IP address, and the second one is going to be the IPv6. My native IPv4 IC, this is coming from the subnet. This is automatically assigned. That is not something which you can access publicly. On these two instances, I need to turn on Apache. So these are the commands basically you need to run. Before you run these commands, you need to get the access. Initially, you can log in with the EC2-user, but you should have the sudo rights to run these commands. This is the testing purpose. When I put these public IP address in the browser, we can see this is the test page which is coming from both the machines. Just for identity purpose, I'm going to change this description here on both the servers. To change this description on the server, you should access this directory and edit the index.html. So I'm just going to mention I'm dual stack server of subnet A, VPC A, and then on the second server I'll mention I'm part of the IPv6, not IPv6, IPv4, and I'm part of the subnet B, VPC A. So let's just start configuring our load balancer. So the name of the load balancer I'm going to mention is lb-demo. This is going to be the internet facing, and I'm going to do only IPv4 testing here. This is very important step. Under the network mapping, basically you need to mention what is going to be the VPC, and that VPC, since I have three subnets created, but I'm only going to use one A and one B. If you recall it, initially I explained you the moment you choose these availability zones, however you can choose multiple zones, AWS is going to launch or spin those many load balancer instances as well. So in this case, I'm going to choose these two. From 1A, I need to mention what is going to be the subnet, and my subnet is going to be the subnet A. IPv4 settings. This is IPv4 address which is going to be assigned by AWS. On 1B, this is my subnet, and IP address is assigned by AWS. On our next step, I need to do listeners and the routing. So listeners means you need to mention what is going to be the port on the load balancer which is going to listen. So I'm going to choose the TCP port 80. So there will be IP address which will be allocated by AWS, and that is going to be the public, and that public IP will be listening on the port 80. However, you have an option to change it since I'm going to test my HTTP services. So this port 80 is okay. And you can add more and more listeners. So if I recall it, maximum you can add 50 listeners, and that is going to be the soft list. And if you want to increase it, you can connect with AWS support and they can guide you or they can edit that limit in your account. Now, after creating listener port, I need to create a target group, and I can create the target group from here while creating the load balancer, or you can go to the EC2 dashboard, and from there also you can create the individual target groups. So while creating the target groups, this is going to be the screen which you are going to get. You can do target type instances, you can do target type IP address, you can do target type Lambda functions and application load balancer. So let's test instances. Let me explain you what it means. So the moment you do instances, it is going to detect how many such instances you're running in your network or in a defined VPC. And if you go for the IP address, you can mention the IP address, which can also be outside of the VPC range. It means if you have a peering which is set up from VPC to VPC, you can route your traffic from here to that particular VPC over the VPC peering. Or maybe you have some sort of the load which is on-prem and you have direct connect kind of the connection. You can also route that traffic to on-prem also. So here you need to define the target group name and you need to mention what is going to be the port your targets are going to listen, and this is going to be the VPC Health Check. In the Health Check, you get multiple options. I'm going to use the TCP. So TCP means it's going to be a very basic check, and it is going to do your TCP handshake on the port which you're going to mention. So TCP handshake means it's going to be the Cincinnati ACK. Based on that, it will decide whether your instance is healthy or is unhealthy, and you can go for higher layered health check. Maybe you go for HTTP. There you can define more options, and that can be interactive as well. So you have a lot of options to do the health check as well. Now we can see, since we only created two instances, it detected those two instances. One is in subnet A, another one is in subnet B, and it is status is running. I can choose what is going to be the target port from here. This is going to be the option which you need to hit, include as pending below. and then you hit the create target groups. We created the target group which is ready, but now it is telling you it is not associated. And the reason behind, we were here on this screen and from here we created it. So any target group what we create, it has to be attached to the load balancer. So you can hit the refresh, and that time it will be populating here what is a target group which you want to associate with this listener or this load balancer basically. You can individually also create the target groups, and if you already have the load balancers running, you can attach it from there as well. Now I have attached it and we will create load balancer. And before that, it also gives you the summary, and in the summary it tells you the basic information. This is going to be the name, and this is going to be the internet facing with the IPv4 only. These are going to be your VPC and the availability zone. Since we have chosen two zones, it means logically it is going to create two load balancers with two different IP addresses, which we are going to see when we are going to access this website. This is the listener. It is listening on port 80, which is going to be the default. And now you can hit create load balancer. Now the load balancer is successfully deployed and we can view it from here. Under EC2 dashboard, now we can see and go to the load balancer, and we see there's a one load balancer which got created, and the state is provisioning. The name is LV-demo. This belongs to VPC ID this, and with two availability zones, and the type of the load balancer is going to be the network, and this is the date when it was created. You also have option to see what is going to be the description, listeners, monitoring, etc., etc. And then you also have, if you want to do or tweak some attributes from here. If you remember, we tried to create only one load balancer and chosen two availability zone. If I do the NS lookup for URL, which is provided by AWS, we can see in NS lookup, it is returning you two IP addresses. So it means more and more availability zones you are going to choose, it is going to provision a load balancer instances. Those are not going to be visible to you, but from NSLOOKUP you can see it. And then the same URL, if I access and keep refreshing the browser, you can see it. In one hit, it is returning a request content which is coming from subnet A, and the second time it is coming from subnet B. So it means my NLB, it is working as expected. If you go to the target group, we can see we added two targets because we had only two EC2 instances running. They both are healthy. Unhealthy, it tells you 0, it means it is working as expected. And under the attributes, you can also see there is also option comes for stickiness. It means you can enable the sticky connections from here while changing the attributes. If you click on the edit, this is basically going to be the screen. You can check box stickiness, connection termination on deregistration. You can enable proxy protocol v2, and you can also preserve the client IP address. Under the load balancer, under the listener, you can see this was the listener which was added, and that is forwarding all the connections to that target group. What if I want to delete it? So I need to check here and hit the delete option. Similarly, this is the option if you want to delete your target group. So you can choose the target group, go to the action, and you see all these options. We will go for the delete one. So we deleted our old target group and the listener, and on the screen you can see you can add more and more listeners from here, and this load balancer thing will stay as it is. Going forward in the next video, probably I'm going to show you how this behavior will look like if you have some workload sitting to another VPC, and that VPC will be located out of that particular region. So we will be communicating over the VPC peering connection. And another thing, or another lab which we are going to do, we will add some resources from IPv6 range. I have not discussed about web application firewall, though I have mentioned that is going to be the key reason. And reason not to add it, the WAF is not supported on NLB, but when you go for ALB, which is going to be the application load balancing, you can use that WAF functionality. So that's it for today, and I will see you in the next video. Thank you for watching.